We have already studied about force in our ninth standard. Force is defined as an external cause which changes or tends to change the state of rest or of uniform motion or the direction of motion of a body. We have to remember about two important units of force. The SI unit of force is Newton, while its gravitational unit is kilogram force. We also are supposed to remember the value of small g, that is 9.8 meter per second square. We shall talk about motion of a rigid body. First thing, definition of a rigid body. A rigid body is one whose size and shape remains the same whatever force is applied to different parts of it. Now, whenever a rigid body is acted upon by a force, there are two kinds of motions possible. First kind of motion is known as translational motion or linear motion. That means motion in a straight line. Now, when does motion in a straight line take place? When a force is applied on a stationary rigid body which is free to move and the body starts moving in the straight path in the direction of applied force, the motion is said to be translational motion. Remember again, translational motion takes place when the body is free to move. For example, there is a ball lying on the floor and we push it, means we are applying a force. Since the ball is free to move, it will execute translational motion or linear motion. Another kind of motion possible for a rigid body is rotational motion. Now, rotational motion takes place for an object when it is pivoted at a point. So, when a force is applied on a fixed point of a body which is pivoted at a point, the body starts rotating about that point. Such a motion is called rotational motion and the force applied is called turning force. We are supposed to remember the word, the object is pivoted at a point. Remember, rotational motion takes place only when the object is pivoted or fixed at a point. You can look at the diagram that is given here. This is a wheel which is pivoted. Pivoted means it is fixed at a point. If we are applying a force F at any edge of the wheel will start rotating about the pivot. The pivot is also known as fulcrum. So, if a wheel is pivoted at its center and a force is applied tangentially on its rim as shown in the diagram, the wheel starts rotating about its center. Again, two kinds of motions are possible for a rigid body. There is a translational motion and a rotational motion. Translational motion is possible when the object is free to move. Rotational motion is possible when the object is pivoted at a point. Now, when an object starts rotating, the force applied is known as turning force. So, next we are going to study about turning forces in detail. Torque or moment of force. We calculate torque or moment of force for an object which is pivoted and is rotating. That means it is acted upon by a turning force. Remember, the other name of moment of force is torque. The turning effect produced by a force on a rigid body fixed about a point. The fixed point can be known as a pivot or a fulcrum is called the moment of force or torque. In short, we often call it to be MOF. So, MOF is moment of force or is also known as torque. The turning effect of force or torque on a body depends upon two factors. Number one, it depends upon magnitude of the force applied, and number two, It depends upon the perpendicular distance of line of action of force from the axis of rotation. Again, torque or MOF depends upon two factors. Number one, it depends upon how much force are we applying. More the force applied, more is the moment of force. Number two, it also depends upon the perpendicular distance of line of action of force from the axis of rotation. Again, more the perpendicular distance, more is the moment of force. Let us see at few equations that help us to calculate torque or moment of force. Torque is equal to, we are talking about the equation here. Torque can be expressed as a product of two things, two quantities. So torque or moment of force is equal to force into perpendicular distance of line of action of force from the axis of rotation. So we say torque is equal to force into perpendicular distance. Torque is also known as moment of force. Since it is the product of force and displacement, its SI unit is Newton meter and its CGS unit is dyne centimeter. However, if we talk about gravitational units, it would become kgf meter and CGS unit would become gram force centimeter. We also have to remember the relationship that is given below. Two relationships actually. 1 kgf meter is equal to 9.8 Newton meter and 1 gram force centimeter is equal to 980 dyne centimeter. These conversions are often used when we solve the numericals. Two more important things to be noted. The torque acting on a body is zero if force is zero or displacement or the distance, perpendicular distance is zero. Remember the equation that we have used above, torque is equal to force into distance. But if force becomes zero, torque automatically becomes zero. Or if the perpendicular distance becomes zero, then also the torque becomes zero, right? So torque is zero under two conditions. Either force is equal to zero or perpendicular distance is equal to zero. Another thing, torque is maximum when the applied force is perpendicular to the axis of rotation. We are supposed to remember torque becomes maximum when applied force is perpendicular to the axis of rotation. Now, since an object is turning around, it can turn around in two ways. Either the object is moving clockwise or it is moving anti-clockwise. If the turning effect on the body is clockwise, then the moment of force is clockwise, while when it is turning anti-clockwise, the moment of force is known as anti-clockwise. Again, if the turning effect of the body is anti-clockwise, then the moment of force is anti-clockwise and it is taken to be positive. We are supposed to remember this. The anti-clockwise moment of force is taken to be positive. On the other hand, if the turning effect on the body is clockwise, then the moment of force is called clockwise moment and is taken to be negative. We should remember clockwise moment of force is negative. You can look into both the diagrams. If you look here in the diagram above, when the force is acted upon the body is moving in anti-clockwise direction. Hence, the moment of force will be taken to be positive. In the diagram given below, when a force F is applied, the object is moving in clockwise direction. Hence, the moment of force taken will be negative. We have been talking about Till now we have been talking about moment of force, wherein we talk about only one force acting on the object. Now we shall move forward to talking about two forces acting on the object. But remember, the two forces are supposed to be equal and opposite. When we have two forces equal and opposite acting on an object, we call it to be a couple. The pair of equal and opposite forces acting along parallel lines, that is not in the same line of action, forms a couple. Remember, a couple always produces rotational motion in an object. We are supposed to remember it always produces rotational motion in the object. Some common examples of couple are opening a tap. Think you are opening a tap. When you're opening the tap, you are using two forces. One force on the finger, other force on the thumb, and both the forces are equal and opposite. Tightening a screw with a screwdriver or steering the steering wheel of a four-wheeler. We come to a new quantity that is known as moment of couple, which is due to two forces now. Moment of couple is defined as the product of force and perpendicular distance between the line of action of forces. Now this perpendicular distance that you can see in the diagram, that is denoted by D, is the perpendicular distance between the two forces which are shown in the diagram. That perpendicular distance D is known as arm of couple. So the perpendicular distance between two forces constituting a couple is known as an arm of couple. So moment equation for moment of couple says moment of couple is equal to magnitude of either force. Remember, we shall consider only one force. We are not going to consider both the forces. Magnitude of either force into perpendicular distance between the line of action of forces. Or you can simply write moment of couple, that is MOC, is equal to F, that is force, into D, that is actually arm of couple. The SI unit of moment of couple is also Newton meter, which is similar to moment of force. Next, we come to something, we shall be talking about something that is known as equilibrium of an object. Equilibrium are of three kinds. There are three types of equilibrium. Before we talk about types of equilibrium, we should know when is an object said to be in equilibrium. An object is said to be in equilibrium if a number of forces acting on it produce no change in its state of rest or of uniform motion. Its motion may be rotational or translational. Remember, when we say that an object is in equilibrium, that does not mean there are no forces acting on it. Of course, there are forces acting on it, but the forces are acting in such a way that its state of rest or state of uniform motion is not changing. Now, in this case, the motion of object may be rotational or it may be translational. We come to talking about types of equilibrium, which we shall talk in the next class.